All right, so let's jump into 12.4. How do I find the inverse of a matrix? All right, well, before we even start, I'm like, what the heck is that? Well, let's talk about this keyword. We know inverse. We've been talking about inverse operations, inverse functions since last year. So I know this is going to kind of be cheesy, but let's go back to something so easy from middle school, right? If 2 times x equals 5, how do we solve for x? Now, I know that we've always said, well, if this is multiplication, you can divide. And that's not wrong, right? We can divide both sides by 2. We undo the multiplication, and we get x equals 5/2. That's not wrong. I'm going to write it again. I spread it out a little bit. Because, yes, we can divide by 2. And we'll talk about in a minute why I'm saying this. But the other way to get rid of this 2 is to multiply by its multiplicative inverse. So instead of dividing by 2, I'm going to multiply both sides by 1/2. And y'all probably think I'm crazy, but I'm doing this for a reason. I know we're going to get the same answer. But we know 1/2 times 2 is 1. And we know 1 times x is just x. And then we go to the other side, and 1/2 times 5 is 5/2. I know the answer is the same. I'm getting there differently. And I know some of you are like, well, that's kind of like the worst way to get there. Yeah, I get that. But hang tight. Yes, I can divide by 2, or I can multiply by the reciprocal of 2, which is 1/2. On the other one, right, we have the square root of 2x equals 5. So the first thing we need to do is undo a square root. And how do we undo a square root? We square both sides. And again, now we're kind of in the same place. We can divide by 2, multiply by 1/2. That to me is like ... I don't honestly care about the answer. My point is, when we want to isolate a variable, we're trying to undo the operation that's currently there. Okay? Like this one. If it says the sine of x equals 0.2, how do we undo the sign? Well, it doesn't say sine times x, right? So we're not dividing by sin. What we've known since geometry is that we can take the inverse sine of both sides. Right? How do we find the inverse of sine? It's just called the inverse of sine. And when we take the inverse of the original, they undo each other, and we're just left with x. What I'm trying to remind you is that there's a lot of different ways to undo operations, right? Division is an undoer of multiplication, but so is multiplication of the right number. Squaring is the undoer of a square root. An inverse sign is an undoer of a regular sign, okay? So let's tie this into matrices. What if I had this equation? What if I have this matrix times capital X, meaning it's a matrix, equals this matrix? We're saying this times what will give me this? How do we isolate matrix X, right? Matrix X. Like the big question is, how do we undo matrix multiplication? And you're going, well, we divide. Okay, great. Let's go grab our calculators. And let's take this matrix. It's a 2 by 2, 0, 3, 15, 8. And let's go divide it by another matrix that's a 2, 4, negative 1, 5, right? How do we undo multiplication? We use division. And the calculator says no. It doesn't get it. It doesn't understand it. In the world of matrices, there is no such thing as division, okay? So that's kind of a big deal, right? I'm going to write this down. Division of matrices does not exist. There's no such thing. So let's go back real quick here. Look, remember back here I said you're going to understand in a minute. Yes, I could divide by 2, but let's pretend that division wasn't in our vocabulary. Is there another way to get there? And what we would want to do is multiply by this, what we call its multiplicative inverse. We're trying to figure out what am I going to multiply 2 by so that that 2 disappears. Oh, it's a 1/2. Okay. So what we want to do is talk about, how do we find the inverse of a matrix, the multiplicative inverse? Okay. So the first thing I'm going to do is talk about the notation. And so I'm going to jump down here, right? So if we have matrix A, for matrix A, its inverse is called a to the negative 1. I know, that seems like the same notation we've been using. Or if it's in brackets, we would leave it in brackets and put that negative 1 on the outside. Again, we know it doesn't mean negative exponent. We know that. We know that this notation means inverse. Okay? So, now, what is the inverse of a matrix? Kind of like what we said earlier with the 2 and the 1/2. If you multiply matrix A by its inverse, you will get the identity matrix. That is truly the definition of an inverse in the matrix world. I'm going back, I know. Remember how I said back here, if I multiply 1/2 by 2, I get a 1. And we said, oh, multiplying anything by 1 just gets you right back to where you were. That's that idea of the multiplication identity property. So the inverse of a matrix is the matrix that we can multiply the original by that will give us the identity. Okay? All right. So a big goal of ours today is to talk about how do we find the inverse? How do I find an inverse? And then tomorrow or in the next lesson we'll talk about why. Why do we find an inverse? I mean, we kind of see it here so that we can undo matrix multiplication. All right, so our big goal today is how do we find an inverse? Now, if you want to find an inverse, the first thing we need is something that we call the determinant. The determinant of a matrix is just a constant. It's a number. I'm going to show you how to find it. Well, before I show you how to find it, let's talk about notation. For matrix A, we could either say det of matrix A, or we could put that in what looks like absolute value bars, but it doesn't mean the absolute value, it means the determinant, okay? All right, so how do we find the determinant of a 2 by 2 matrix? So if you have matrix A that has elements A, B, C, D, the way we find the determinant of that matrix, which can also be written like this, is to multiply the main diagonal. So we're going to multiply A times D, and then we subtract your other diagonal. Order matters because of subtraction. So you do the main diagonal coming down, and then you subtract the other diagonal. So this is how we calculate the determinant. Okay. Now, what if it's a 3 by 3, a 4 by 4, a 5 by 5? How do we find the determinant? Well, we're going to use a calculator, and I'm going to show you how to do that. Use a calculator. I'm not saying we can't do it by hand. I'm just saying in this class we are not going to do that by hand. Okay, so we'll come back to the calculator in just a minute. All right, so for matrix A and matrix B, they're asking us to find the determinant of A. So I'm going to go to matrix A, and the determinant says we're going to multiply down the main diagonal. So we're going to do 3 times 7, and then we're going to subtract our other diagonal, which is negative 2 times 4. And so we have 21 plus 8, which is 29. Now, this is meaningless right now. I absolutely get it. But in order to continue with our lesson, we first had to take a time out and talk about how do we find this thing called a determinant. because a determinant is used to find an inverse. All right, let's take a look at this next one. It says find the determinant of B. It's the same thing, different notation. So again, we're going to multiply our main diagonal, so 2 times negative 6 minus negative 3 times 4. So we've got negative 12 plus 12 for a determinant of 0. All right, so the next thing I want to talk about is how do we find the determinant on a calculator? So I'm going to start with the inspired. If you want to find a determinant on your calculator, we're going to go to our menu, and we're going to go down to number 7. Oh, there it is. Number 3, determinant. So it says the determinant of, and I need to put a matrix in there. So I'm just going to pick the first one, 3, negative 2, 4, and 7. Right, and we know that. We got that by hand. So again, on the Inspire, I hit menu. I went down to number 7, and then I went down to number 3, and then you put your matrix in there, right? And you can either type your matrix in there, or if you have a matrix stored, you can just put the letter in there, okay? Let's talk about our 84s. It's going to be very similar. We have a matrix menu. Oh my gosh, it's zoomed in so much. I'm sorry. We have our matrix menu here. So I'm going to hit second matrix. And I'm going to go over to the math menu. And the very top one says determinant. And then I can put a matrix in there, however it is that, whatever we have. So let's go check the second one. So we have 2, negative 3, 4, and negative 6. Okay, so I'm going to write that down for the 84. We hit second, x to the negative 1, which is our matrix menu, M-A-T. Well, on some calculators it may not spell it all out. We went over to math, and then we chose 1 for determinant, and then it did the same thing. It said, what do you want the determinant of? And then you go throw a matrix in there. Okay. Good. All right, so now that we know how to find the determinant, let's talk about how we use it to find the inverse. So, given a 2 by 2 matrix A, so we're only going to know how to find the inverses of 2 by 2s. Its inverse, A inverse, is found by doing the following. So, matrix A is full of these 4 elements, A, B, C, D. Its inverse will be 1 over the determinant of A. Remember, the determinant is a constant. We are going to switch A and D. So they switch places. And then we're going to change the signs of the other 2. So we switch the main diagonal. We change the signs of the other diagonal. All right, here we go. Here's matrix H. It's a 2 by 2. The first thing I need is the determinant. So the determinant is 1 times 2 minus negative 1 times negative 3. And so I get 2 minus 3, which is negative 1. That's my determinant. All right, so here we go. I have 1 divided by negative 1. All right, well, we know that's negative 1. I'm going to switch the 1 and the 2. They switch places. And I'm going to change the signs of the other 2. Then we're going to clean it up. 1 divided by negative 1 is negative 1. And now I have a scalar product. And so now I'm going to go in and multiply everything by that negative 1. So this is H inverse. And I want to show you how to check that on a calculator. So on the Inspire, I'm going to take my matrix. It is a 2 by 2. oops, sorry, I need to be typing in the original. I'm checking my inverse. I'm typing in my original. 1, -1, -3, 2. The nice thing is, on this calculator, on the 84 too, we are going to say raise it to the negative first. We're using the same notation, and look at that, -2, -1, -3, -1. Perfect. That's how, and we'll do this again later, so I'm not going to write it down. Same thing on the 84. I'm going to take my 2 by 2 matrix, which was, oh, come on, Kristen, which was a 1, -1, -3, 2. I'm going to go to the outside, and then I'm going to go hit that button that says, oh, x to the -1. I'm going to just check something real quick. I want to see if we can do it like we did on the Inspire. Yes, we can do it the same thing on the Inspire. You can either use the caret and raise it to the negative first, or you can use this x to the negative first button. Okay, let's do another one. It says find the inverse of matrix C. Again, the first thing we need is the determinant. 4 times 2 is 8, minus 2 times 3 is 6, and 8 minus 6 is 2. All right, so here we go. C inverse equals 1 over the determinant, so 1 over 2. I'm going to switch the 2 and the 4. I'm going to change the signs of the other 2. Great. Which means when I perform the scalar multiplication, 1/2 of 2 is 1. I get a -3/2 or -1.5. I get a -1 and I get a +2. There's my inverse. Now, I could check this on a calculator, right? But I'm asking us to check it a little bit differently. It says, let's verify by showing that when you multiply matrix C by its inverse, you get the identity matrix. All right, so let's do that. Let's take C, which is a 2 by 2, and let's multiply it by what we think the inverse is. And the reason I'm asking us to do this is because it's going to really help us remember what the heck an inverse does. I think we can do this by hand. We're multiplying a 2 by 2 by a 2 by 2, so we're going to get a 2 by 2. All right, here we go. My left hand's going side to side, my right hand's going up and down. 4 times 1 is 4. Move both hands. 3 times -1 is -3. Add those together. Moving over. 4 times -1.5 is -6. 3 times 2 is 6. So I get -6 and 6. We're going to add those together. Second row, first column. 2 times 2 is 2. I'm sorry, 2 times 1 is 2. 2 times -1 is -2. We're going to add those together. And 2 times -1.5 is -3. Move both hands. 2 times 2 is 4. We're going to add them together. And let's see what we get. We get a 1 here, a 0 here, a 0 here, and a 1 here. And there it is. That's our identity matrix, right? Zeros everywhere except on the main diagonal. All right, let's finish with this question. Do all matrices have an inverse? All right, well, I don't know. Let's start with the calculator. Just to kind of check. So let's take this 2 by 2. Whoops, I didn't mean to do that, sorry. It's a 3, 2, -9, -6. And let's raise it to the negative first. And it says error. And we can't even see what the rest of it says. So I guess the answer is no. Let's see why. Let's try to find the inverse. So let's start with the determinant. 3 times -6 is -18, minus 2 times -9 is -18. -18 plus 18 is 0. It'd be pretty darn hard to find an inverse by doing 1 divided by 0, because we know we can't divide by 0. And there's the problem. So, do all matrices have an inverse? The answer is no. When our determinant is 0, that's going to be a huge problem for us. Okay, now listen, we already did this. I got ahead of myself. That's okay. Let's talk about a 3 by 3. Let's go find the inverse of a 3 by 3. So I'm going to get it all typed in. 1, 2, -1, 0, 4, 3, 1, -5, 2. And I'm going to raise it to the negative first. Oh, it's not so pretty looking, but it's the inverse, right? Like, oh, look at all those fractions. Not great, but we could go write that down, okay? Let's talk about what this would look like on the 84. I'm not writing down the answer. You get what I'm trying to do here. So let's get out of here. Let's go grab a 3 by 3. I'm going to get all these things typed in. And again, I'm going to raise it to the negative first. Now, at first glance, it is a mess. A lot of your 84s are not going to show you everything, and they are not going to spit out fractions. But do not freak out. The very next thing I'm going to do is I'm going to hit my math button. I'm going to hit my math button, which is right here. And I want to take that answer and turn it into a fraction. So as soon as I do that, it says, oh, you want me to take the answer and turn it into a fraction. And it's going to take all 9 of those elements that we couldn't even see before and put them in. And that's obviously great for 2 reasons. One, now we don't have to round anything. But more importantly, now I can see the whole matrix. Versus back here, I couldn't even see the whole thing. You know what I mean? No, it's turning that into a fraction again. Sorry. So try. Ask the calculator if it can turn it into a fraction for you. That's going to make everything a lot easier and more accurate.